Hi, grade nine. Welcome to topic 6.3, which is graphing linear relations. And today what we're going to do is the first part of this is just we're going to review what we did in topic 6.1. We're going to build a table of values, get an equation, and then actually do a little bit of graphing or plotting points on a coordinate grid today. So we'll start with the first one, and example number one here. We're graphing from a table of values. So we're going to create a table of values for this pattern or linear relation. And we have rectangle 1, rectangle 2, rectangle 3, rectangle 4. And what we're going to do is construct a table of values. And we have rectangle number here. And we're talking about the perimeter. Common mistake is people want to do area all the time, but we're talking about the perimeter of each of these rectangles. So if we make a table of values for this pattern, we have rectangle number 1. And if we look at the perimeter, it'd be 1, 2, 3, 4, 5, 6. So if we count each one of those lines as one unit, that would have a perimeter of 6. Again, 1, 2, 3, 4, 5, 6. Rectangle 2, we'd have a perimeter of 1, 2, 3, 4, 5, 6, 7, 8. So we can put rectangle number 2, and we have a perimeter of 8. And we carry on with rectangle 3 and rectangle 4. And rectangle 3, if we count it out, has a perimeter of 10. And rectangle number 4 has a perimeter of 12. So we've built a table of values based on this pattern. And we have to describe what's happening in words, or I could write it out, or we can just talk about it. But as you see, the rectangle numbers are increasing by 1 every time. Plus 1, plus 1. So these are going up by 1, and the perimeter is increasing by 2. So if you wanted to describe this in words, you could just say that. As the rectangle number increases by 1, the perimeter increases by 2. That would be perfectly fine for description in words. We can build an equation. You did this in topic 6.1. And to build the equation, again, we always start our equations in the form of whatever's in this part of the table, or I guess the y part, is we're going to write it as p equals. And again, in 6.1, you talked about what each of these are increasing by per one of the rectangle numbers, and that is increasing by 2. So that is going to be our coefficient or our multiplier on this variable. So the first part of my equation is p equals 2n, and then I have to figure out the constant part, or the last part of this equation. So if I take 2 times my rectangle number, or n, so 2 times 1 is 2. Well, how do I get from 2 to 6? Well, I am going to add 4. And what I would do is I would just double check to make sure that works for the rest of these. If I go 2 times 2, I get 4, plus another 4 does get me to 8. 2 times 3 is 6, plus my 4 here does get me to 10. So my equation for this linear relation is p equals 2n plus 4. We often use the variables they give us in the table, so p and n, but we can also use x's and y's. You'll see that more and more. And whatever's in this first part of the table is always the x value. This is always the y value if I was talking in terms of x and y. So that is just a quick review of what you've done in topic 6.1. You made a table of values, you wrote an equation, you described what was going on. Now what we're going to do is we're actually going to throw this into a graph. And I've kind of made the x and the y axis for you. I've built them so it's a little bit easier to see. But as you can see from my table of values, whatever is in the first part or the left side of the table, this is always going to go on your x-axis or your horizontal axis. This will always go on your y-axis or your vertical axis. So when I made this table of values, made the graph, you can see I have rectangle number on the x, perimeter on the y, and it always follows that way with tables of values. So what we'll do is we'll just plot these points, and these are just ordered pairs. So in our table of values, my first point, I have rectangle number 1, I have a perimeter 6. So here's rectangle number 1, and my perimeter of 6 is right here. Now, I started this x-axis at 0, but I didn't start the y at 0 or 1. I have a little break in the graph here, and you've done this in previous years just to shift the graph down so it's not starting way up here on the y-axis. So I just shifted this axis down, and you can do that at the beginning of a graph in your y-axis and your x-axis, just not in between somewhere kind of halfway through your graph. So rectangle number 1, perimeter 6. Rectangle number 2 has a perimeter of 8, put a point there. Rectangle number 3 has a perimeter of 10, and rectangle number 4 has a perimeter of 12. So we've just plotted these points, and we can see that we have a linear relation. It's a straight line graph. And what we do need to talk a little bit about is some of the things with graphing that you will come across in the future. And again, what I put on my x and y axis are a couple definitions that you need to understand are something called dependent and independent variables. So dependent and independent. Dependent variables always go on the y-axis. So in this one here, my dependent variable is the perimeter, okay? So this value depends on the value of the x-axis. So the perimeter is dependent on, the perimeter is dependent on let me just fix this graph. 2 was 8. I'm struggling a little bit today. There we go. So the perimeter is dependent on the rectangle number. So it always goes on the y-axis. That is your dependent variable. Your independent variable always goes on the x-axis. And this is, by definition, the value that can be freely chosen. Now we can make this a little bit easier to understand if we use another example. So you'll get data sometimes, and it won't tell you what goes on the x and what goes on the y-axis when you're graphing it. And we just can't throw stuff wherever we want. It has to go in a particular spot. So, for example, if I was to do collect some data of the number of times you brush your teeth, and so I'm gathering information on how many times you brush your teeth and also the number of cavities that people have, they have in their mouth. Okay, so these are the two things I'm collecting data on. How many times you brush your teeth, how many cavities you have. And I'm collecting data in a population. And I want to graph my results. So I have to figure out which goes on the x-axis and which goes on the y-axis. So which one's the dependent variable and which one's the independent variable? Well, if I was going to graph this, I would put on my x-axis the number of times you brush your teeth, and on my y-axis, I would put the number of cavities. Now, why I would do this? I choose freely how many times I brush my teeth, and generally speaking, the number of cavities I have is dependent on how many times I brush my teeth in most cases. So this is my independent variable, which would go on the x-axis. This is my dependent variable, which would go on the y-axis. So when you are graphing items, it's a good idea to put them in the right spot. This again, independent goes on the x, cavities are dependent on how many times you brush your teeth, so this goes on your y-axis. So that's why in this case here, in this one, my perimeter is dependent on whatever rectangle number I have. So that's why this is on the x, this is on the y. Again, in tables of values, the first one is always your x, the second one is always your y in tables of values. So just some things about graphing. The other thing that you need to know a little bit about, something called discrete data and continuous data. Once we plot points, people always want to just go ahead and join these points together to form a graph. Now, we don't always join points on graphs, and discrete data points are not going to be joined. For example, in this one, I didn't join the points. Now, the reason being is, if we look at another example here, so if I have an X and Y axis, and let's say I have on this one, let's say I'm buying tickets for a hockey game, concert, whatever it is. So here I have here number of tickets, and here is the cost. Now again, independent variable, number of tickets. Okay, I can freely choose how many I'm going to buy. The cost is dependent on how many tickets I buy. So this is on my y-axis. This is my dependent variable. This is my independent variable. Now, if I'm buying tickets, okay, so I buy one ticket at this price, whatever it is, the tickets are the same price. So another ticket here, 3 tickets, 4 tickets, and so forth. I have a linear relation, straight line graph. Now, I would not join the points here because I am buying 1 ticket, 2 tickets, 3 tickets. There is no information in between here. I'm either buying 1 ticket, 2 tickets, 3 tickets. So this is an example of discrete data. I would not join the points on this graph because there's no information in between. I'm buying 1, 2, 3, 4. I'm not buying 1.5, 2.5 tickets, and so forth. Likewise here, rectangle number. I don't have rectangle number 1.5 or 1 3/4. I have rectangle 1, I have rectangle 2, I have rectangle 3. I do not join points in between because there is no information here. So that is what discrete data is. Continuous data, I would join the points. And a typical one discrete type data question or graph, I'll just give myself a little bit of room here, would be you do a lot of distance and time graphs. So here I have my time, whatever I'm traveling for, let's say it's in hours, and here's my distance I've traveled, and let's say that's in kilometers. Well, after 1 hour, 2 hours, 3 hours, 4 hours, I've traveled certain distance. Let's say it's consistent. So I've traveled, and here's my graph. It's straight line. I would join the points on this graph. And the reason I join them, I'll just join them with a line here. So we've got a straight line here, okay? I would join those points. And again, the reason I would is because in this case, I can travel for parts of time. I can travel for 1.5 hours, 1 hour and 3/4. I can cover parts of a kilometer. I can travel 50 kilometers, 55 kilometers, 53.7 kilometers, whatever it is. So I would join the points on continuous data because there is information in between the points. So just, it's not something you have to memorize or anything. Just be aware that independent variables always go on the x-axis, dependent variables always go on the y-axis, and we do have discrete and continuous data. Discrete data, we do not join the points because there is no information in between. Continuous data, we do join the points because there is information in between. So just a couple things to be aware of when you are graphing linear relations. So we'll flip over the page here, and again, we've got another, we'll just go through a quick example here. I've set up an X and Y axis, but here's the information we've got. We're going to graph this data, and the data is number of DVDs. Obviously, this is a pretty old example, and how many I've rented and what the cost is. And again, you can see these are increasing by 1 every time. And looks like these are increasing by 350 every time. So we do have a linear relation. We've got consistent increases in the x-axis, or in this one, and we have consistent increases in the y, so it is going to be linear, a straight line. It says graph the data. Does it make sense to join the points on the graph and explain? So if I graph this stuff, we've got 1 DVD is at 350, 2 is at $7, 3 is at 10.50. 4, get rid of that. 4, we've got how much? $14. and 5 is 1750. And we could carry on if we wanted with this graph, but you can see it is in a straight line. And doesn't make sense to join the points. So would I join this, or what it's asking is this discrete or continuous data? Well, I can't rent 1.5 DVDs. So there is no information in between these points, so it doesn't make sense to join the points in this graph. So this would be discrete data. All right, so that would be answering A. I've graphed it. We've talked about discrete and continuous. Is this linear? Justify your answer. Well, if I look at the actual visual graph, it is a straight line. It is a linear relation. If I look at the table of values, we've got consistent increases in the x-axis. We have consistent increases in the y-axis. This is a linear relation if it's consistent in both axes. So B, yep, linear, we're good. It says use the table to describe the pattern in the rental cost. How is the pattern shown in the graph? What that means is if you look at the table, as my numbers of DVDs rented increase by 1, my cost is increasing by 350. This is also shown in the graph because I have an increase here in my x-axis. I'm increasing by 1 here, and in my y-axis, I'm increasing by 350. So what's happening in the table is also shown in the graph. Again, we've got an increase of 1 here, and then we've got an increase of 350 there, increase of 1, increase of 350, increase of 1, increase of 350 every time. So the table and the graph are showing the same thing. Well, let's have a look at this next example. And in this one here, you'll notice that we're just given the equation of a linear relation, and we're asked to graph it. We have a table of values, or sorry, we have an equation right here. And we have, here's my equation, and we have a table of values, and we've got a chunk of graph paper ready to be filled in. So how do I graph this onto here if I'm just given that? So what I would do is I would choose some values for x, and I would use some substitution or a little bit of algebraic process to figure out what my y value is. So if I, for example, choose 0 for x, what I can do is I can substitute this x value into this equation, and it will generate a y value for me. So if I take that, so here's my equation, y equals 3x minus 5, and I have an x value of 0. So I have y equals, and I'm going to put in a 0 for x, and I have minus 5. Well, I know that 3 times 0 is 0. 0 minus 5 is negative 5. So when x is 0, my y value is negative 5. Now I have an ordered pair that I can plot on this graph, and I do the same thing for some more values of x. What do I choose for x? Well, choose nice numbers. Don't choose 3.2 million or 375,354.214. Choose x is 0, x is 1, and I do the same process. So if I take, in this case, my same equation, y equals 3x minus 5, and I put in a value of 1 for x, 3 times 1 minus 5, and I figure out what my y value is. 3 times 1 is 3 minus 5, and we have negative 2. And all I do is build a table of values, and sometimes it'll tell you how many to use or which x values to use, but if I chose these ones, I substitute them in algebraically exactly like I did here. For this table of values, I would generate these, and if you want to try these just to make sure you get the same y values as me, then go right ahead. There's my table of values. Again, all I've taken is the x's, put them into this equation, generate my y's. Now I have a whole list of ordered pairs that I can plot on this graph. And if I take them, and we know 0 is negative 5, so here is 0 and negative 5, 1, 2, 3, 4, 5. There's that point. 1, negative 2, 1 over and 2 down would be right there. 2 and 1, 2 and 1, looks like it's right there. 3 and 4, 1, 2, 3, 1, 2, 3, 4. And 4 and 7, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. And the rest of it's going to go off the graph, so we'll stop there. And there's my graph. Now, you might ask, okay, well, I've plotted my points. Would I join these points? And in this case, I would say absolutely yes, you can, because you can have x values of 0.5, 0.75, 0.2, and you could generate a y value. So there is information in between these. So if I took my line, I would join these points to form my linear relation. So this is continuous data. So that's graphing linear relations. We'll do one more example. And in this one here, same type of question. However, the equation's written a little bit differently. We still have it as y equals, but this case it is 6 minus 3x. Now, if you don't like this written this way, then if you want, you could write this same equation, just put the 3x first, but that sign attaches to it. So I could write this same equation as negative 3x plus 6. These are the same thing. So if this kind of bothers you a little bit, then just write it like this, but make sure you attach that sign. That's negative 3x and positive 6, so negative 3x, positive 6. You could write it either way, and it will be perfectly fine. So it asks me in A to create a table of values for this relation, this linear relation, and it does tell me in this case to use values of x from negative 3 to positive 3. So here's my x values, here's my y values, and it does say negative 3, 2, negative 1, 0, 1, 2, 3. So these are all the x values it wants me to substitute into either of these and generate some y values. Now I'll do the first couple with you. And then if you want, you can fill in the rest of the table and we'll graph this thing. So here's my equation, and I've got y equals 6 minus 3x. And I'm substituting in a value of negative 3 into x to figure out my y. So here I have my y, and I have 6 minus 3, and then I'm multiplying by negative 3. Now, how I like to look at this. I like to go negative 3 times negative 3, so this is going to be 6 plus 9. Okay, so if I have 6 here, I look at this as negative 3 times negative 3, so that's 6 plus 9. So that would make this 15. So when x is negative 3, my y value is 15. Now, if you don't like that, negative 3 times, let's do it this way. Let's look at it here. So in this one, you didn't like that, and you say, well, no, that's a subtraction sign, not a negative sign. So I have 6 minus, and if I go 3 times negative 3, that's negative 9. 6 minus negative 9 is positive 15. So either way you look at it, you're going to get 15 here for your y value. Now, if you take the same equation, but we rearranged it in this form, so I have y equals negative 3x plus 6, and my x value is negative 3. I have negative 3 times negative 3 plus 6. Negative 3 times negative 3, there's my positive 9 plus 6, y equals 15. So either way I do this, whichever equation I use or form, I'm going to get a y value of positive 15 when x is negative 3. So what I'll do next is I'll do the negative 2, and we'll go from there and see how everyone's doing. So I'm going to get rid of this piece right here, and we'll do the same thing. So I've got my y equals 6 minus 3x, and let's go x negative 2. And there's my x value of negative 2. That's a 6 here. Okay. So I have 6, and negative 3 times negative 2 is positive 6. So my y value is 12. If I use this equation, negative 3x plus 6, and I take my negative 2 for x and put it in here. So y equals negative 3 times negative 2 plus 6. This gives me positive 6 plus 6. So either way, that gives me that value of 12. Probably should try and fill some of these in on your own. I'll give you the y values for all this. But if you want to try and see if you can get those, because this equation is maybe a little bit trickier than the previous one. Maybe not, I'm not sure. But when x is negative 1, y is 9, we have 0 and 6, we have 1 and 3, we have 2 and 0, and when x is 3, this is negative 3. So there's my table of values. Now I would just go ahead and plot these points. Just be careful on this graph. These are going up by ones, but I only labeled them every 2 just because I can't write neat enough in here to just go up by ones. But those lines are each going up by ones. You'll notice the y-axis here. I do go up by 2s here just so I could fit the information that I needed to in this graph. It's not the best, but this is 2, 4, 6, 8. So just be careful when you're plotting these points. And if I plot these ones, so negative 3 and positive 15. So here's negative 1, negative 2, negative 3, and then positive 15 would be, what is that, 16, so 15, so there's 14. So you're going to have to kind of estimate this one just a little bit. So this is negative 3, 1, 2, 3, and 15 would be about, there's 12, 14, so right about there, okay? So it's not on an exact grid line. Negative 2 and 12, so here's negative 1, negative 2, and 12 should be right here. Negative 1 and 9, so here's negative 1, and there's 8, there's 10, so 9 would be right about there. 0 and 6 would be right here. 1 and 3, there's 1 and there's 3 right here. 2 and 0, right there. And then I could go 3 and negative 3, but I guess I can get that one on there. So here's 2, there's 3, so it'd be about there. All right, would you join the points? Well, I can have x values in between each of those, so absolutely yes, this is continuous data. I would take my line, and I could join those points, and I have my linear relation. So that is topic 6.3, graphing linear relations. And there will be a handout, not a textbook assignment for this one, a handout that you can work through and complete. So good luck with that, and take care.